Our first speaker is Jonathan Overpeck. Professor Overpeck, or Peck, is a Regents Professor of Geoscience and Atmospheric Sciences, and also the Thomas R. Brown Distinguished Professor of Sciences, both at the University of Arizona. He is a climate scientist who has written over 200 published works on climate and environmental sciences and served as the coordinating lead author for the Nobel Prize-winning Intergovernmental Panel on Climate Change. Peck has active climate research programs on 5 continents, loves trying to understand drought and mega-drought dynamics the world over, and is also the lead investigator in the climate assessment for the Southwest and Southwest Climate Science Center, 2 major programs focused on regional climate adaptation. Please welcome our first presenter, Jonathan Overpeck.
Good morning, everybody. It's great to be here in Logan. It's still summer down in Tucson, so seeing snow really warms my heart as a skier. I just wish I could come up to Utah more often. Today's talk concerns everybody in Utah, as well as the 7 basin states of the Colorado. And what I want to do today is show some old results, but really the main thing is to show new results. In work that I've been doing with Brad Udall at Colorado State University, trying to get a better idea of what is ahead for the Colorado River. And one thing I wanted to point out is, this is part of my work is as a contributor to the DOI, Department of Interior, Southwest Climate Science Center, but we're also, many of you know Jack Schmidt and some of the other folks who are involved in this Colorado River Research Group, something that formed under 2 years ago. And we've put out 7 policy reports so far. And the latest one that just came out this week has to do with what I'm talking about today, climate, futures, and the Colorado. So if you want to learn more and you want to have something you can hand to your stakeholder buddies who might not be into the nitty-gritty science but are really interested in the implications and what they can use, these reports can be very useful. Or just give them to your politicians because they need to know this too. Okay? Everything's online. The big thing that's going on out here in the Southwest, and most of our folks back east don't fully get it, I don't think, is drought. And they, of course, know that California's been in a drought for 5 years, and that's captured a lot of imagination in the national press. What's gone kind of unnoticed, though, is that the Colorado River Basin, or the greater Southwest region, including California, but including the interior Southwest, has been in drought since 1999 or 2000, depending on how you look at it. For the Colorado River, it's been since 2000. But in some parts of the Southwest, it stretches back a little further. And I've had some folks come up to me and say, hey, that drought started in 1997. The point is that this drought has been really the drought of instrumental record since we had rain gauges. It is eclipsed the 1950s drought, the 1930s drought. Any droughts that our parents and grandparents can remember, this is the drought of record. And what's wonderful about the Colorado is we have built this amazing infrastructure to kind of buffer ourselves from that, this kind of drought. And what we're at right now, as you'll see, is this close, literally a foot of water level in Lake Mead down there near Las Vegas. We're just this far from the first declared shortage. So this infrastructure is designed for droughts that last 10, 15 years, but longer, hotter droughts as we're in now could pretty much upturn the apple cart. So as you can see, the drought now is still worse, the reddest colors, the brown colors in California. That drought certainly hasn't gone away, even though they've started to relax their water restrictions and things. We're hoping for a good winter, and for sure the storm that just came is a good portend for that. But after I'm done talking, you tell me what you think you'd bet on, okay? The drought is still gripping much of Arizona. Utah, it's not so bad, but I bet you some of your rancher buddies know that it hasn't totally gone away. If you go and look at the drought over the course of it, and these are just 4 snapshots, you can see that the drought has moved around. And one of the big things you have to realize with drought, whether it's here in the Southwest or in the Mediterranean, Southern Africa, Australia, any other place that's really drought prone, is that droughts don't just stick in one place and stay dry year after year after year. They move around and they're punctuated with good years, and it's really more the long-term hydrologic, ecological impacts of these droughts that really define them after they're over. And you can see that this drought was really bad early in the century, 2002, 2004. That's when we were literally killing pinon pine in the Four Corners just outright before the beetles even came in. The fires really started to rage. The drought moved out in the high plains, 2012. That gave the Dust Bowl parts of the country a reason to say, oh no, I guess there's something going on. 2013, it was down there in New Mexico. I can remember doing a Senate testimony that Senator Bingaman was really worried about what's going on in New Mexico. This thing has moved around and it's given everybody a sense of how bad it could be, and as you will see in my talk, is likely to get. Okay? The purpose of this talk is to focus on the Colorado, and Utah gets about 10% of its water from the Colorado, or it gets 10% of the water flowing in the Colorado. It's about 15% of your water, you hope. Just like in Arizona, we hope we get our allocation. It's a big water basin. 7 states, as you can see, and Mexico share this water. And it's no surprise to anyone here that it's one of the fastest growing parts of the nation. People want to live out here where we live. They want to drink water from this Colorado. Lots of large cities, the ones in red, including LA and Vegas and San Diego and Phoenix and Tucson, Albuquerque, Denver, someday Salt Lake. We all get our water from this. We get appreciable, ranging from like all of it to some of it, our water from this basin. Over 30 million people are using water from the Colorado for urban and agricultural and other purposes. And it really is huge ag and very important ag for our country, because we're providing not just up here a lot of warm season production, but we're also down in our neck of the woods in the lower basin producing much of the vegetables that we consume in the winter. And there are also a lot of tribes, and it's really important to keep this in mind, in part because they have claims to this water. They have senior rights to this water, many of which are not yet adjudicated. So even though we've allocated 16.5 million acre feet, that's a lot of billions of liters, of water each year, some of the native nations still haven't settled their claims. So there's really a lot of demand on this river that hasn't yet been fully tied up with a bow. And the most important thing for you to realize, and I think most people here do, I mean, you're lucky you have the mountains right here, but for much of us in the Southwest, this is our sustainable water supply. And if you don't think this is your sustainable water supply, well, the story I'm about to tell really is the same story for your supply as well, as Sarah Null pointed out very nicely in the last talk yesterday. Okay? I was just at a meeting a month ago in Arizona when all of the politicians, the water managers, the scientists, anyone and everyone who cares about the Colorado gets together at the Arizona Hydrological Society annual meeting. And a couple of things that I heard there coming from the mouths of water buffaloes, meaning people who really can control and influence how we use the water. Advisors to governors, leads of the agencies that manage the water, both state and federal, this is an unprecedented drought. Check, they got that message, that's wonderful. Below 1025 is a nightmare scenario. Well, we're almost at 1075 feet, and that refers to the level of Lake Mead above sea level. And that is how we gauge sort of when doo-doo hits the fan and how badly it hits the fan and what kind of shortage agreements kick in. And we've dipped down below 1025 this year, but it's really at the end of the year that matters. So we're going to release water from Lake Powell upstream And you guys all know where these big reservoirs are, right? There's Lake Powell right here at the Arizona-Utah border, and there's Lake Mead where we're talking right now. The two biggest reservoirs are in the country, right? These are important. But at 1075, we start getting a shortage, and the junior water users start getting cut off. That includes mostly Arizona and Vegas. But as things go down further, we reach eventually, and as a scientist, I can tell you it could happen very quickly, 1025. And below 1025, we don't really know what's going to happen. And as you know, reservoirs are shaped in river valleys like this, so they can go faster and faster as you get down into the depths of the shortage. And the other thing you have to realize is that the water allocated in this river is 16.5 million acre feet. It's a convenient unit that water users use. Sorry, it's not metric. But the long-term flow of the river is really around 14.7. Okay, so we have some of this is called a structural deficit, but I just call it we've really over-allocated. And that's the reason why when we start hitting these shortages, even if we make cuts, unless we get a whole lot of snowpack and way above normal flows, the river almost has to keep cascading to worse levels of shortage. At this meeting, I also heard two things that really perked and I've heard this before, including from the head of the Metropolitan Water Authority in LA, and those guys have senior water rights, and they are really good at making sure they get their water, as all of you probably have read about in things like Chinatown and movies and things. We can't control what Mother Nature does, okay? We can't control the hydrology. In other words, the water manager at the stage now where they're worried about drought, they're worried about putting into place agreements to deal with the drought, figuring out how to adapt and get through it. They haven't quite figured out that this isn't like a drought of yore. It's not like a drought where it goes down and it comes back. We're talking about something else, which I'll get to in a minute, where it's going to get ratcheted worse and worse. But they haven't come to realization that they can do something about what's going on. It's not Mother Nature that's controlling the hydrology. It's us. Okay, what do I mean? Well, first, let's just see the state. Powell's at 53, about half full. Okay, that's the upper basin main storage. And Lake Mead is 37% full. These are the big intakes for the Boulder-Hoover Dam. Okay, the water should be up here. The water should be going in through these intakes. This is really unprecedented. Okay, the average flows in this century have been, on average, year by year, 19% below normal. This is an important number to remember, 19% below normal since 2000 on average. That's looking at Lake Mead there, and you can see that they've been very innovative and they're moving the marina down as the lake drops. Okay? Here's a good way to sort of picture it in a more quantitative way. Okay? What we're looking at on the top is the combined storage of Lake Mead and Powell, okay? And they're in millions, acre feet here, millions of acre feet here, and then if you've really got to know billions of cubic meters on the outside, you can read those units. But the important thing is we built the dam back in the 30s. This is then Boulder Dam, became Hoover. And we filled up Lake Mead. And then the 1950s drought hit, and it's really the 50s and 60s. People like to say the 1950s drought, but it's really the 50s and 60s. And everyone said, ooh, we better do something about this. And that's when we really got into even more of a dam building frenzy out west. And we had the big fights, and we built the Glen Canyon Dam. We decided not to build dams in the Grand Canyon main stem where the national park is now, but just upstream. And we filled that up. And it filled up until the 1980s, and boy, things looked great then. Small dip, small drought during the 90s, and then filled up. I moved to Tucson from Boulder, Colorado, 1999, and one of my very first talks I gave on the Colorado from U of A was in Vegas. And I was invited there by the Southern Nevada Water Authority, their big water organization, agency. And I said, all the managers were just beaming because the lakes were full. and there was no problem, and Vegas was in boom mode, and I was the poor sucker saying, you guys should be worried about drought. You really got to worry about drought and climate change. And they were just kind of laughing at me. Okay, and then 2 years after I left that meeting, things plummeted. And Mother Nature backed me up for once. Usually when I talk about drought, it rains and snows. Okay, so expect a good ski season. Okay, but it just plummeted. And the first couple of years were really bad. And now it's really interesting to hear the water managers saying, well, at least it's stabilized. Things are good again. But yeah, it's stabilized at half full. And as you know, recently it's gone down even more. So we're really kind of like right above the poop hits the fan stage, all right? And there have been these two droughts, the 1950s, 60s, and the current drought. And look at this. This is the actual natural flows. The natural flows are naturalized flows at Lee's Ferry, just downriver from you guys in Arizona, all right? And this is where we measure the water coming out of the upper basin going into the lower basin. And you can see over the course of 1910 to present, there's just been the dotted line. The real fine dotted line is just flat. That's average flow. And you can see it's below 15 million acre feet. I think of the tree rings when I tell you it's lower than that, because really the longer term average flow is lower than the instrumental flow. The 20th century was wet. Okay, but then there's this dashed line, and that's the long-term trend. It's down. You can see a low frequency curve here just showing you beginning of the 20th century. When did we allocate all that water? 1920s. That's Mother Nature's little joke on us. It was the wettest time in the last 1,000 years. Well, anyhow, we went down during the 1950s, and then it came back up, as I've already said, and then went down during this century, all right? What I'm going to make the point here is that we have two different droughts here. We have the 50s, 60s drought and the current drought. They're fundamentally different, okay? Because now we're going to look at the cause of those droughts. Here we're looking first at precipitation. Again, the lines mean the same. The long-term trend and the long-term average are the same. In other words, there hasn't been any long-term trend in precipitation in the upper basin of the Colorado. This is where this river flows come from, right? Up here where you guys live in Colorado, right? And you can see during the 1950s, there was a good dip, big dip in precipitation. That was a precipitation-dominated drought. Because if you look at the temperatures were about the same as average. There's that dotted line, average, 1950s, 60s, average temperatures, really low precipitation, all right? Contrast that with the droughts in the 21st century, and you can see the precipitation is long-term. Well, yeah, there are a couple bad years, but there are a couple good years. So it was about average over the long haul of this 16-year drought and counting. What's different about this current drought is we're about 1 degree C warmer than we were at the beginning of the 20th century. So we've seen over this period of 100 plus years a warming of 1 degree C. We have seen no change in precipitation. We've seen a steady decrease in flows. What do you think the story of my talk is? Okay? It's all about temperature, and people are thinking, it's all about precipitation. That's great if you're a farmer and you're worried about this year, or a rancher and you're stocking. But if you're worried about the long-term haul, temperature is just as important. Okay? This is the challenge of hot drought. And I wrote a little opinion piece on this a couple years ago saying, hey, heads up here, it's not all about precipitation. Climate change is going to drive our region into a drier and drier state. It's going to make mega droughts, regular droughts, more likely. It is going to really reduce water supplies and dry out our landscapes. Okay, that's what I'm talking here about. Okay, so I already mentioned this, that since 2000, the average annual flows of the Colorado have been 19% below normal. Okay, I showed you what normal was a minute ago, about a little under 15 million acres. What about the future? Okay, there have been multiple reams now, this is like a cottage industry, to write peer-reviewed scientific literature on what the flows are going to be like in the future. One commonality among all the publications is that the flows are going to go down. The projections range from 1 to 45% down by the middle of this century, assuming a range of climate change scenarios. And Sarah in the last talk yesterday, I hope you all heard, did a nice job of describing all these scenarios of greenhouse gas emissions, because I'm going to build on that. The most recent published study is from the Bureau of Reclamation in their Secure report in 2016. It is by far the rosiest picture we've ever seen for the future of the Colorado. And it really troubles me that they have said that don't worry too much because the latest climate models suggest there really isn't a problem. And as a climate scientist, I'm here to tell you there really is a problem. Okay? So let's get into the future a little more. And as Sarah pointed out, a lot of the future really depends on us. There's a lot of uncertainty in terms of what the ocean will do with the greenhouse gases. It takes up a lot of them, fortunately. And what it does with the temperature. The ocean takes up over 90% of the trapped heat. So just a little burp of the ocean can really make a difference to global temperature. But the biggest uncertainty about the future is what will we humans do on this planet? Will we continue to emit greenhouse gases, CO2 and methane, nitrous oxide, and others, at an ever-increasing rate? Or will we all take the agreement in Paris and more recently in Rwanda? Will we take these international agreements seriously? Remember, they're not really heavily binding, especially the Paris one, and we'll reduce the greenhouse gas emissions. And as scientists, all we can do is we can look at the range of possibilities for humans got their act together and reduced the emissions versus humans just let things rock and roll, business as usual. And this is the kind of comparison you get when you do that. On the left is something called the RCP, Representative Concentration Pathway 2.6. These are just the way scientists, the Intergovernmental Panel on Climate Change, talks about their emission scenarios. But you can imagine this is a very, very aggressive reduced greenhouse gas emissions scenario. Okay, more aggressive than Paris. Okay, I'm going to show you what Paris does to the Colorado in a minute. Okay, that's versus the RCP 8.5, which is business as usual. Okay, not necessarily worst case, but business as usual. And this is global temperature averaged across a whole host of models. One of the things I'm going to do in my talk later is I'm going to disaggregate all these models. Everyone loves, like the Bureau of Reclamation, to just put them all in the hopper and get the average. You'll see why that's probably not so smart, if you're a manager at least. But this is just looking at the average warming. If we really get serious about greenhouse gas emissions in our neck of the woods, we'll just be another 0.5 degree to 1 degree, okay? Whereas, so double about what we've got now. Whereas if we go pedal to the metal, it'll be 5 to 7 times warmer than it is today. So remember that. That's our choice, really. Double what we've got so far versus 5 to 7 times. By the end of the century, we'll all be long gone by then, but it'll keep warming then if we decide to go that route. In other words, this red map on the right is nothing compared to what it'll be 100 years henceforth beyond that. Okay? Now, as a climate scientist, one of the things I want to do is give you a sense of what goes through my limited brain when I'm trying to talk about odds of something happening. How do I assess uncertainty? When it comes to temperature, this is the kind of thing I do. I look at all the models, okay? What went into that ensemble? About 39 different climate models, and many of those models are simulating many, many times, okay? So they're really trying to get an idea of what the statistical distribution of temperature projection is. And you can break that out and look at the coolest. Oh, wait, all of them show warming. That's interesting. Every single model simulation for the future shows warming, okay? So it really comes down to, is it going to be a little warming, 4 or 5 degrees for this RCP 8.5? Or is it going to be a lot of warming, 7, maybe more degrees C? Okay. This is assuming business as usual. Every single model suggests warming. Okay? So bottom line, if you're a betting person, is you can bet your house, you may, everything you got, that it's going to get warmer over the course of this century if we don't reduce greenhouse gas emissions. It's a sure bet. Okay? Why do I say that? Well, when the projected change is consistent with theory, back in the 19th century, okay, over 100 years ago, we knew about the greenhouse effect. It's pretty kind of simple physics, okay? You increase greenhouse gases in the atmosphere, you have to trap more radiation. You have to warm the planet. But, you know, we're scientists. We're always testing hypotheses. That's a very strong hypothesis. That's why it's called a theory, okay? But is the projected change consistent with ongoing change? Hell yeah. All the models say it should be warming, and it is warming. It's warming a lot around the globe, and it's warming a lot here in the United States and the Southwest. We're ground zero for the warming, in fact. When is the projected change consistent amongst most models? Well, every model suggests it should be warming, and that just adds to my confidence. When the physics in the model match the physics we observe in Mother Nature, check, okay? So on all counts, it's a slam dunk. We're going to get a lot more warming, okay? Now, why is this so important? It's because I'm tired. I work a lot with decision makers and stakeholders in the public, and I'm tired of people saying, well, that's too much uncertainty. Very few stakeholders really can't deal with uncertainty, but they can use it as an excuse, okay? We deal with uncertainty all the times in our lives, right? It's just a crazy idea that we can't deal with that, okay? But when it comes to temperature, there's not nearly as much uncertainty. We know it's going to get warmer. It's just a question of how much. So we can take a study like this, which included myself, but led by Julie Vano, then a postdoc of Dennis Lettenmeyer. And anyone who knows river modeling knows that we're talking about the grand guru of Colorado River simulating. We had Levi Brecky here, the lead scientist for the Bureau of Reclamation. We, in fact, had a number of other scientists. And what we were trying to do in this study was try and reconcile. Remember I said we had all these studies projecting into the future? We tried to bring everyone together and say, let's all use the same scenarios. Let's use the same assumptions. Let's figure out and reconcile what the real flow reductions are going to be. And we concluded in this paper and earlier papers that Julie wrote for her graduate work that warming alone will drive Colorado River flow declines of 6.5% plus or minus 3.5% per degree C. Okay, that's one standard error. All right. So remember that somewhere between 3 and 10% reduction per degree C warming. Okay, why is that? Okay. People, hopefully are starting to really understand the role of temperature here, and we watch it every single winter, it seems, in the upper basin. A warmer atmosphere simply demands more moisture, okay? So it has to get that moisture somewhere. We observe the moisture content of the atmosphere going up. This is not theoretical or projected, it's happening. It was projected when I was in grad student. My gray hair should tell you that was a while ago, all right? We knew it was going to happen. It has happened. Okay, as the atmosphere warms up and needs more moisture, can hold more moisture, it demands that moisture. Okay, it gets it from sublimation, it's going up. It gets it from evaporation, it's going up. It gets it from evapotranspiration from plants. Okay, this is the big term in the upper basin. Most of the moisture going from the surface to the atmosphere is going via the plants and soils and evapotranspiration. Turns out that the warming is causing the growing season to extend. It's over a month longer now because of this warming. So the plants can start growing and evapotranspiring. And of course, they're getting fertilized by CO2. Most people think that means they can close their stomata and don't have to release as much water. But hell no, they're growing. And in all likelihood, there's more plants growing now, so more evapotranspiration. Just emerging in the scientific literature now that might be the truth. We don't know for sure, okay? More rain, less snow. Anyone who's been skiing knows what that does to the snow. More rain on snow, it's not a good thing. I'm not even talking about positive feedbacks like dust on snow or the effect on cloud. or the effect of a drier atmosphere on the temperature. All these things are positive feedbacks, okay, that contribute to these numbers we see up here. All right. So if you just take the temperature, the sure bet thing, and you try and you understand how that will hit the flows of the Colorado, this is the kind of picture you get. And we're in final review in the water resources research with these results. So they're hopefully will come out before the end of the year. What's on this plot? What we've got here is flow decline in percent. Talking about the Colorado in the future, you don't have to talk about flow increases. And then we've got 4 different panels. They're divided right through the middle. This is mid-century projections. On the right are end-century projections. And for each of those, we have moderate emissions, which is RCP 4.5, and high emissions, RCP 8.5. Pedal to the metal, business as usual, versus Paris, if everyone did what they agreed to. Okay? And then we're looking at the individual models, okay? Because every single model, and we're using both CMIP 3 and CMIP 5 here for people who understand that kind of stuff to really get an idea of what the full range is. We're taking the temperature simulated for the upper basin for every single model simulation. And we're looking at the range for 3% reduction per degree C warming, 6.5 in blue, and 10% per degree C reduction in red. Okay? And up here is what we believe is already, for that range, been lost to temperature, okay? Somewhere between 4 or 3.5, let's say 3 degrees. It's more close to 3, because it's been a little under 1 degree C warming, 3 to 9, okay? So that's the range we've lost already, we think, due to temperature. And you can see by mid-century, if we reduce our emissions or not, because it doesn't really make a difference too much by what we do now for 2050. It makes a much bigger difference by end of century. The median reduction is somewhere between 25 and 30%. If we're at the high end, which personally I think we are at, the 10% per degree C loss, or it could be lower, you know, in the 15 range, 20% range if we're in the median. But wait a minute, we've already lost 19% on average per year, okay? So that's one of the reasons I think we're probably at this high end, the sensitivity, maybe higher because of the feedbacks, okay? By the end of the century, these numbers get much bigger, and you can really see the effect of whether we actually follow through on Paris or not. But you know, if we don't follow through on Paris, some of these models are showing a lot of warming, and the degrees of warming here is along the bottom, which you don't really need to pay attention to, but the warmest models are suggesting we could get flow reductions in the 60 to 70% range by the end of the century. The median is around 55, okay? Unless we agree to cut emissions, then we get a savings of about 20% in terms of flow reduction. And of course, everyone who did Paris is hoping that that is just the start and we'll reduce emissions more. Okay? What about precipitation? You know, the Bureau of Reclamation is saying, well, the basin's going to get a lot wetter, kumbaya and all that. Let's look at what we think about precipitation. Here are the driest models by the end of the century, again for 8.5. They show drying in the upper basin. The wettest models show it gets a little wetter in the upper basin, just by 0 to 10% wetter. The stippling shows no change. Most of the middle models, of 50% of the models, suggest no change. Okay? So the models are kind of like, well, it could get drier, it could get wetter, it couldn't change, it might not change. What do the observations tell us? No change. Okay, there hasn't been a little trend at all. Okay, so if you're a betting person, what do you bet on? Oh, it's going to get wetter. Okay, I suggest you immediately go down to Vegas, start pulling that lever, because that's what you're doing here. All right. The bottom line is the Colorado River will get hotter without doubt, and the basin is not getting wetter. Okay, maybe we'll luck out and all of a sudden things will change, but there's a lot of climate science that suggests that dry zones the jet stream, the storm tracks, should be moving poleward in both hemispheres. We see it clearly in the southern hemisphere, where it's helped by the ozone depletion in the stratosphere, and we're seeing it in the northern hemisphere as well. Okay. So, but some of the models don't show that. They're wetter. Let's hope they come true. Okay. I would say plan for drier, hope for wetter. But then take note. Let's just say I'm going to sport you to a whole bunch of quarters, and you can go and you're going to win playing the slot machine of greater precipitation. Now I'm going to tell you the slot machine's never going to pay off. All right? Because there also is a problem of drought in this region. Everyone knows we're in a drought-prone region. Okay, droughts happen. If you look at the tree ring record, you see droughts that last decades. Those are called mega droughts in our literature. Okay? They are more likely with greater warming. So if you get a drought like we're in now, it's been 16 years, and it goes to 30 years, or goes to 40 years, or even 50 years, what do you think that means about the value of mean annual precipitation increase? It negates it. Okay? The longest mega drought we've seen in the headwaters of the Colorado and the Rio Grande is 50 years, with 1 year above normal in the tree ring record. Okay? A paper that we published a couple years ago talked about the probability of such mega droughts in the future. They are not well simulated in the models. You have to use the paleoclimatic data and the models to get bias-corrected drought estimates, and the probability of a 35-year mega drought in this century is 25%. And if a 50-year mega drought is lower, 5%. Okay? I don't know if anyone saw the news last week, but the idea is that the warming alone will drive the Southwest with almost a perfect chance, if we leave emissions at the rate they are now, will drive the Southwest into a permanent megadrought. I don't know if that'll happen, but boy, with those kinds of odds, I wouldn't be betting on more rainfall saving the day. So in conclusion, the last few years of this century has been an excellent example of what the coming rest of the century is going to look like. Only hotter, unless we reduce our greenhouse gas emissions. Okay? The Colorado River is not the only river at risk. That's one that's getting all the studies, but the story is the same for the Rio Grande and many of the other rivers in the interior Southwest, okay? And California for that matter. The reductions in flow of the Colorado could be 50% or more if we leave emissions unchecked. Okay, that's a lot higher than is commonly acknowledged, and it's higher than the scientific literature heretofore has suggested. And it's because we've separated out the roles of a certain temperature increase and a much less certain precipitation increase that is likely negated by drought impacts, mega drought impacts. What good is a precipitation increase if you get a drought that goes for 35 years? Okay. Continued warming will increase the odds of the multi-decadal drought significantly. I showed you those odds. I think those odds might be conservative. I'm guessing they're conservative. If you read our paper, we say they are. Most of the research we've done since then suggests they are conservative. By the way, you can keep up with all of this by following me on Twitter. This is what I like to tweet. I don't tweet what I did with my dog. Okay. Warming is not a friend of the Southwest, clearly. But I also want to leave you with a sense of just not great despair. This is a real opportunity for us. There's good news. The good news is twofold. Think of yourself, I've done this recently with my dad. I've gone to the doctor thinking he's got some serious bad problems. Every doctor up to then has said he's got about to have heart failure. I take him to the cardiologist, and the cardiologist tells me, no, it's not that. It's something else. It's much less severe. Take him off of those stupid heart drugs. And so, bingo, it meant so much to me and my father when we figured out what the true cause of the problem was, okay? You could just ignore the cause. You could deny climate change. But it's power in your pocket if you know what the cause is, because then you can treat the cause. You can switch to the right drug. And in this case, the drug is climate change mitigation if you want to solve this problem. We can control hydrology. We can control Mother Nature now. We are in charge with our greenhouse gas emissions, okay? And the second thing to realize is to do that climate change mitigation, we need to switch to low carbon, no carbon energy. That's the number one thing. Get rid of the fossil fuels. What part of the country is going to benefit most from that? Yeah, there's some oil and gas and coal in our region, but there's also a hell of a lot of wind and solar potential. We will be the place that is generating most of the energy for this country, not just some. With that, I think I'm done. Thank you.